students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as rotational. Let's find out the moment of inertia of a disc. Moment of inertia of disc. Now in order to find out the moment of inertia of a disc, let's find the moment of inertia of a disc about an axis. Passing through the center of the disc, passing through the center of the disc, and perpendicular to its plane. Now let's try to draw our disc. Let's consider a small element of the disc. Let's consider a small element of the disc. Let's consider O as the center of the disc. Let capital R be the radius of the disc. Let R be the distance at which the given element is from the center. Let the length of the element be equal to dr. Let the axis of rotation pass through an axis perpendicular to the center. Right, pass through the center and perpendicular to the disc. Right, so you will say, let us consider a circular disc of mass m and radius r. Right, rotating about an axis, passing through the center. And perpendicular to the plane. Now, let us assume, let rho be the mass per unit area. In that case, I can say that the surface area of the disc is nothing but pi r square. Therefore, I can say that mass of disc is nothing but pi r square rho, because this is the mass per unit area and this is the area of the disc. So total mass of the disc will be mass per unit area into the total area. Now the circular disc can be imagined to be consisting of large number of extremely thin concentric rings. The circular disc can be imagined to be consisting of large number of extremely thin concentric rings right? Now let's consider one such ring of mass m. Consider one such ring of mass m and radius r. So in which case I can say, as the entire mass of the ring is the same, as the entire mass of the ring is at the same distance, as the entire mass of the ring is at the same distance from the axis of rotation, the moment of inertia of the ring can be given by the formula moment of inertia of ring I. Moment of inertia will be nothing but mass into radius square. Basic formula of moment of inertia, mass is m r square. Now let us assume, let dr be the thickness of the ring. If dr is the thickness of the ring, then I can say that the area of the ring is going to be nothing but the circumference into thickness circumference is nothing but 2 pi r, thickness is nothing but dr, right? In that case, what will be the mass of the ring? Mass of the ring is mass per unit area into the area. Area is nothing but 2 pi r into dr, right? Now, in that case, I can therefore say that moment of inertia of ring was mr square. M we found out as rho into 2 pi r dr into r square. So this is 2 pi r cube rho dr, right? Once I have this, then I can say this is the moment of inertia of the ring. The disc can be considered to be made up of multiple number of such concentric rings. Therefore, I can say that moment of inertia of the disc is nothing but I, which will be nothing but moment integral of the moment of inertia of the ring 2 pi r cube rho dr. Now what will be the limits? The minimum radius is 0, the maximum radius is capital R. Whatever is constant comes outside the integral sign, so 2 pi rho comes out, 0 to r cube dr. Integral of r cube is nothing but r raised to 4 divided by 4. So 2 pi rho r raised to 4 divided by 4 when the limits are between 0 to r, right? So in which case substitute upper limit minus lower limit. So this is going to be equal to 2 and 4 gets cancelled. So this is going to be pi rho upon 2. This will be r raised to 4 minus 0 raised to 4. Upper limit minus lower limit. So this is going to be pi rho r raised to 4 divided by 2. Right? Now, this can be written as r raised to 4 can be written as r square into r square pi rho upon 2. But pi r square rho is nothing but mass of the disc. So this is nothing but mr square divided by 2. So thus the moment of inertia of the disc about an axis passing through the center and perpendicular to the disc is nothing but mr square divided by 2. Now, how do I find out the radius of gyration for this? I can say that if k is equal to the radius of gyration, then I can say k is square root of I upon m. K is square root of I is mr square by 2 upon m. So that is square root of r square upon 2, which is nothing but r upon root 2. Fine, do we get this? Now, we found out moment of inertia of the disk about an axis passing through the center. Now let's find out the moment of inertia about an axis coinciding with any one of the diameter. About an axis coinciding with any diameter of the disk. Let's consider a disk, right? Let's assume that you have x, y and z axis. Let's consider this to be my y axis. This is my x axis, and I have z axis that is going to be perpendicular to these. So this is going to be my z axis, about which the axis is, which is going to pass through the center O. Okay, so you have x axis, y axis and z axis. Okay, so we'll consider, let two mutually perpendicular axes OX and OY be drawn on the disk. Let two mutually perpendicular axes OX and OY be drawn on the disk, right? Be drawn on the disk with center O. Of the disk as the origin, center O of the disk as the origin. So that's what we've drawn. Now I can say that the third axis OZ is perpendicular to the plane of the disk. The third axis OZ is perpendicular to the plane of the disk, right? In which case, let's assume that Ix, Iy and Iz are the moment of inertia of the disk, about x, y and z axis, right? Then I can say by theorem of perpendicular axis, I can say Iz is equal to Ix plus Iy, right? Now I can say, as the moment of inertia is the same about any diameter, the diameters are same, I can say as moment of inertia is same about any diameter, therefore I can say that, let's consider that as Iz is equal to Ix will be equal to Iy, both are diameters. So this is my moment of inertia about any diameter. Now I can say that Iz is Ix plus Iy, which can be written as Iz is, I can substitute Iy as Ix, so I'll get 2Ix, but moment of inertia, therefore Ix I can say is Iz upon 2, but moment of inertia about an axis perpendicular to the disk and passing through the center of the disk, we found out is nothing but mr square by 2. So this is nothing but mr square by 2 into 2. So this is going to be nothing but mr square by 4. So that will be the moment of inertia of the disk about an axis passing through the diameter. Right? What will be the radius of gyration? Radius of gyration is nothing but I upon m, which will be square root of I mr square by 4 upon m. So this is going to be nothing but r by 2. Radius of gyration will be r by 2. Next, let us find out the moment of inertia of a disk about an axis coinciding with a tangent in the plane of the disk. About an axis coinciding with a tangent in the plane of the disk. So let's assume that this is my disk, right? This is my moment of inertia about any diameter which is passing through center C. I want to find out the moment of inertia about an axis which is tangent to the disk. Now let's assume that the radius of the disk is r. This is my point of intersection, right? So you will say consider a tangent drawn at point O. At point O. Consider a tangent drawn at point O of the disk. Right? Draw diameter parallel to the tangent. Draw diameter parallel to the tangent. Right? Let us assume that IO is the moment of inertia of the disk about the tangent. IO is moment of inertia of disk about the tangent. Right? Let us also assume tangent at point O. Let's assume that IC is the moment of inertia about the diameter. About the diameter. Right? In which case I can therefore say by theorem of parallel axis, I can say that IO is equal to IC plus MR square if I apply theorem of parallel axis. Right? Now in this case R is the distance between IO and IC, where I can say that R is represented by capital R. So therefore I can say that I and IC, moment of inertia about an axis which is passing through any diameter, we just found out is nothing but mr square by 4. Therefore I will get IO is equal to mr square by 4 plus mr square. So IO is equal to 5 mr square by 4. Right? So that will be the moment of inertia about an axis coinciding with the tangent in the plane of the disk. Fine, do we get this in here? What will be the radius of gyration for this? Radius of gyration, that is K, is square root of I upon M. So this is nothing but square root of I, 5 mr square by 4 upon M. This is nothing but root 5 by 2 R. Right? That will be my radius of gyration. Next, let's find out the moment of inertia of the disk about an axis coinciding with a tangent but perpendicular to the disk. There it was in the plane of the disk. Now you want it perpendicular to the plane of the disk. About an axis coinciding with coinciding with a tangent perpendicular to the plane of the disk. Right? Let's draw your disk. Right? Let's assume that this is the axis passing through the center. Right? This is your z axis. I want to find out moment of inertia about an axis which is parallel to the z axis and is a tangent to the disk. Let's assume that it is tangent at point O. This is y axis. This distance we know is nothing but the radius of the disk, right? Okay, let's assume tangent is drawn to the disk at point O. Let tangent be drawn to the disk at point O. Let's assume that a tangent is drawn to the disk at point O and perpendicular to the plane of the disk. Right? In which case, this tangent is going to be parallel to the axis of the disk. This tangent is parallel to the axis of the disk. Right? Now let's assume that IO is the moment of inertia of the disk about the tangent at point O. IO is moment of inertia of the disk about the tangent at point O. Let's assume that IC is the moment of inertia. IC is moment of inertia about the disk. Moment of inertia about the disk passing through the center of the disk. Passing through the center of the disk. Right? In that case, I can say by theorem of parallel axis, by theorem of parallel axis, I can say that IO is equal to IC plus MR square, where I can say R is the radius of the disk and IO is going to be nothing but, IC is nothing but the moment of inertia of the disk about an axis passing through the center and perpendicular to the disk, which we found out as MR square by 2. Therefore, I can say that IO is equal to MR square by 2 plus MR square. This is nothing but 3 MR square by 2. Right? So that is going to be my moment of inertia of the disk. Now, if K is the radius of gyration, if K is radius of gyration, then I can say K is square root of I upon M. So which is going to be nothing but square root of 3 MR square by 2 upon M. So this is going to be root 3 by 2 R. Right? That will be the radius of gyration of a disk. So these are the different ways in which you can find out the moment of inertia of a disk. Right? Okay, we'll stop this here for the day. Thank you very much.